Okay, so for this next video, I'm going to show you another method, and it's making use of the mass ratio. So the first method was making use of the mole ratio. So for every 8 moles of the first reactant, I'm going to need another mole of the second reactant in order to form 1 mole, 4 moles, and 2 moles of these products respectively. Now, for mass ratio, I'm not going to make use of moles, okay? I'm going to make use of the masses. So when you need 8 moles in your reaction, how much does 8 moles of this NO2 reactant weigh if each mole weighs 46.01 grams? So you need to multiply this out. So if a mole of this reactant weighs 46 grams, then 8 moles must weigh 36.08 grams. Okay, so I just multiplied the coefficient and the molar mass. So here, this reaction or this recipe calls for 1 mole of the second reactant. So a mole of the second reactant weighs 555.47 grams. It will produce the products 1 mole of titanium 4 nitrate. And since a mole weighs 295.91 grams, then that means the weight of the product form must be 295.91 grams as well. If I form 4 moles of the product NO and each mole weighs 30 grams, then the total mass of NO that I will form will be 120.04 grams. And if there's 2 moles of I2 formed, and each mole weighs 253, then I double the mass. So the mass formed or collected will be 507 grams of iodine. Now, if you notice, the mass coming in must be this equal to the mass coming out. And so if I add these two reactants, 368 plus 555, that gives me a value of 923.55 grams of total masses coming in. And the amount coming out from the reaction, if they are all in stoichiometric amounts, the amount of products coming out must also be the same. Okay, remember the law of mass conservation. What comes in must come out, and so the masses must be equal. That is, if the reactants that you dumped in your vessel are at stoichiometric proportions. All of them will be used up in the reaction, nothing wasted, nothing in excess, and all of them will form into these products. But that's not always the case. When you're doing this reaction, sometimes you just dump in whatever is available in the lab, right? So in this case, you dumped in 19.7 grams of NO2 and 24.2 grams of TiI4 in the vessel. So if I'm going to show that in the picture, dump in 19.7 grams of the first reactant and dump in 24.2 grams of the second reactant, okay? Now, chances are these are not at stoichiometric proportions. Are they? You can do a quick check, right? So is the ratio here 368.08 over 555.47? The ratio here is, for that stoichiometric amount, is 0.67, okay, or 0.66. If you compare the ratio of these masses, 24.2 grams, if that is 0.66, then they are stoichiometric amounts. Nope, they're not. The ratio is 0.81. So they're not stoichiometrically equal. So one will eventually run out first. So you're going to figure out which of these two reactants will run out first. Not necessarily meaning if you have the least value, it doesn't necessarily mean that that is the one that will run out first. You have to do some analysis in order to figure out to do that. So I'm going to first do this first step. Method 1. find the limiting reactant. How much of the product can I produce if all of my 19.7 grams of the first reactant is used up? Now remember, I'm going to make use of the mass ratio. For every 368 grams of the reactant used, I can make 295 grams of the first product. And that will give me 15.8 grams. On a separate calculation, I'm going to figure out how much of the product is formed if all of the second reactant is used up. If you look at the mass ratio, for every 555.47 grams of the product reactant used, I make 295.91 grams of titanium 4 nitrate. Okay. So this is similar to that first method wherein you're comparing the products formed. Based off the two, this reactant gives me the least amount of product, which means to say that this is my limiting reactant, okay? Or the second reactant is my limiting reactant. So by the time I use up all 24.2 grams, I can only make 12.9 grams of the product. It's impossible for me to make 15.8 grams because by then all of this titanium 4 iodide is used up. Now that I know that this is my limiting reactant, my next step is to calculate the other products or the other amounts based on the limiting reactant. Okay, so 12.9 grams. I already know that from this method. So the second method, the second part is to find the rest of the products. Okay, so let's try to do that. How much NO is produced if all of the 24.2 grams of the limiting reactant is used up? And this time I'm going to use mass ratio. For every 555.47 grams of the reactant, I can make 120 grams of NO. That gives me a value of 5.23 grams. Okay, and I'm going to do the same thing for iodine. That's 507 grams. And the value is 22.1 grams of iodine. Okay, so what that's, let's just paint a picture here for a bit. So I let this reaction occur. I mix the reactants up. I'm going to have a drain valve here after the reaction. Let it run for a long time to ensure that the reaction occurs. So here What came out were the products: 12.9 grams of titanium 4 iodide, 5.23 grams of NO, and 22.1 grams of iodine. So that's what it means, okay? What else does that mean? It means that what's coming out, since all of the titanium 4 iodide or the second reactant is consumed, there's nothing left. If you drain everything out, there's nothing left. Nothing of this TiI4 that's left in the reaction. But there's still some NO2 that's left, right? Because we said that it's still in excess. So there's still some extra unreacted nitrogen dioxide. How do we calculate for that? So we could do it in two ways. We can calculate for the amount of NO2 that is used up in the reaction. Based on the limiting reactant. And it tells me that the amount that is used in the reaction is 16 grams. Okay, so remember, you dumped in 19.7 grams of NO2, but only 16 grams of that is used in the reaction. That means to say what is left in unreacted is what you dumped in minus what is used in the reaction. That gives you 3.7 grams. What happens to those excess? It's just going to come out together with the products. Okay, so if you add all of these things that's coming out of your vessel, that's 43.9 grams. It's going to add up to what is coming into your vessel. So 24 plus 19, that's 43.9. Okay, so meaning to say, you actually don't have to do all of these calculations in blue. If you add all of these products formed and then subtract it from 43.9, you're going to come out with 3.7 grams. And that's the amount of the excess or the unreacted NO2.